Did you know that the widespread impact of insulin resistance is because it activates multiple survival pathways? Let me explain. In an otherwise healthy patient, there should always be glucose in circulation. The brain in particular is highly dependent on glucose to function. The body needs a constant supply to survive. We get glucose from the breakdown of foods by the digestive tract. A constant supply of glucose needs a constant supply of insulin. This is because the body cannot use glucose for energy without insulin. In the presence of blood glucose, insulin is secreted by the pancreas. Insulin stimulates the expression of glucose transporters GLUT4 that creates a point of entry for glucose from the bloodstream and into the cells where they can be used for energy. Glucose is in a constant state of movement between intracellular and extracellular spaces. When the expression of GLUT4 decreases, glucose will lose its pathway for entry into the cell. If glucose cannot get into the cell, it remains in circulation, causing hyperglycemia. As blood glucose rises, like when we eat, insulin secretion from the pancreas also increases, which means GLUT4 expression also increases. When we are not actively eating, the influx of blood glucose into the blood decreases, which means insulin release also decreases and GLUT4 expression will also decrease. This is how we maintain normal blood glucose ranges. The pancreas has this rhythm of basal release and bolus release. When there is a high concentration of glucose in circulation for a long period of time, the pancreas loses this rhythm. The beta cells of the pancreas are pumping out insulin all the time. After an initial appropriate response to increase the expression of GLUT4 transporters, the insulin receptors on the cells start to become desensitized to the high levels of insulin. That means there's an actual decrease in the physiological response to insulin. So that even though blood glucose levels are high and insulin is being secreted, there is actually a reduced expression of GLUT4 transporters. This is a threat to survival. Regardless of the cause, all your body knows is that it does not have a constant supply of energy that it needs to support critical organs like the brain and red blood cells. In the most basic terms, your body thinks that you can't find food, that starvation is imminent, so it kicks into survival mode beginning with the secretion of glucagon. Glucagon is secreted from the alpha cells of the pancreas when blood glucose levels are actually too low or perceived to be too low, as in the case of insulin resistance. Glucagon release will initiate metabolic processes that will supply the body with the glucose it needs from endogenous sources, like glycogenolysis, where glycogen is converted to glucose by the liver, and gluconeogenesis, where new glucose molecules are made from non-carbohydrate sources like amino acids and fats. You can find out more about these metabolic processes at pharmacology.com. The endogenous glucose is released into the bloodstream, further worsening the high concentrations of blood glucose. The body is in a battle against itself. It is a very stressful state. Glucagon release, glycogenesis, and gluconeogenesis are intended to be temporary pathways to sustain us to the next supply of exogenous glucose. The constant expression of glucagon is very tasking on the body. In fact, glucagon release is accompanied by the secretion of stress hormones like epinephrine, cortisol, and growth hormone. Together, these hormones are preparing the body for what it perceives to be a threat. This is why the expression of insulin resistance covers a range of conditions beyond just hyperglycemia, like diabetic ketoacidosis, obesity, and infertility. This video is part of a larger discussion of insulin resistance and its role in DKA, obesity, and infertility. Head over to pharmacology.com to access the complete unit.